Hello everyone, Samar here. Today I'll be talking to you about electrical current. In order to remember what electrical current means, all you need to remember are the three E's, which stand for electricity, energy, and electrons. Electricity is defined to describe the energy produced when electrons are caused to flow in one direction from atom to atom. The movement of these electrons is what we call electrical current. If you didn't get that definition, just go back to the beginning and watch until now. Then we can move on to solving electrical current problems. Now that we know what electrical current is, we can now move on to knowing what the formula is. So the formula that we were given in physics class was I equals Q over T. Now, this just looks like a bunch of letters. So let's try to figure out what these variables mean. So, easily, the T stands for time, which is usually, and most probably, you should put in seconds. Q stands for charge, which can be written in the unit of C, standing for coulombs, and I stands for current, which we put in amps. Simply put, the term amps is often used for short, and an amp is the amount of electrical current that exists when a number of electrons having 1 coulomb of charge moves past a given point in 1 second. So, 1 amp means that 1 coulomb of charge passes every second. We can also write this as 1A equals 1 C per second. When it comes to solving for Q in an electrical current problem, we must rearrange the formula that we're given. To reiterate, our formula is I equals Q over time, or T. Now, if we're solving for the Q, we obviously have to leave it alone and isolate it. So we have to get rid of this T. Now to do that, what do we have to do? Oh yeah, multiply this T on this side and that side in order to get rid of it. Simply put, I times T equals Q over T times T. This T and this T cancel each other out, isolating this Q just as we want it. So, in final, our formula for solving for Q in an electrical current problem would be I times time equals Q. Let's try doing some practice problems. Alright, it's time to try a practice problem. Let's read our question. How many electrons measured in coulombs result from a current of 15 amps for 24 hours? So, as this question already reveals, we are solving for Q, but using the grasp method, let's look at what we have. So, in G, which stands for given, we are given 15 amps in 24 hours. So, amps stands for current, which is I, so we can put 15 amps under I, and we are also given time in hours, so time is equal to 24 hours. Now it's time to look at our required. We are solving for Q, which does stand for charge, so we're going to write Q equals unknown. And then for A, which is analysis, we have to analyze the question and see exactly which formula we need to solve it. As from the previous slide, I times time equals Q should give us the answer we require. Then it's time to put out our solution. Now, before we do put in our variables, substitute our variables for our information, we do need to convert our time into seconds, just so it's easier and we have an accurate answer. So, it's time to do some conversion factors, which I will do in the corner of the screen just so we have more space. So 24 hours. So we all know that in 1 hour there are 60 minutes, and that in 1 minute we have 60 seconds. So we'll cross out our hours, cross out our minutes, and we should be left with seconds. If you do put this into your calculator, you would multiply 24 by 60 once more, and your answer should be 86,400 seconds. So I'll put that right over here just to remind myself that that is the conversion in seconds, 86,400. Perfect. Now it's time to move on to our solution because we have converted everything into what we need it to be converted into. So our formula, again, is I, current, times time. So we can put that in. 15 times 86,400 should give us Q. And if we put that into our calculator, our answer should be as follows. Voila. And then you have to account for significant digits. As seen in previous videos, if we count back our original numbers, we'll see that we need to have 2 significant digits in our final answer. So if I rounded this, I would be getting there we go, all matched up, 5 zeros at the end, and that should give us our charge. But it's always better to put everything into scientific notation just so it's neater, though this is the correct answer. So if we were to put this into scientific notation, we would write, let's look at how many decimal places we have to go. So 1.3 times 10 to the power 6 coulombs is equal to Q. That's perfect. And lastly, part of our grasp situation, we need to paraphrase. So our paraphrases usually start with therefores. So we're going to write therefore 1.3 times 10 to the power 6 coulombs of electrons result from a current of 15 amps for 24 hours. And if this was on a test or a quiz, you should be getting perfect because you've shown all of your work, your conversion factors, and you've used grasp to its fullest capabilities. And that's about it. So we've learned about isolating for Q, what electrical current is, and remembering the 3 E's in order to remember the definition, which stands for electricity, energy, and electrons. I hope you learned a lot from watching this video, and if you have any further questions, you can either consult in your textbook or comment below.